Hello everyone, my name is Chinmay Srivastava and currently I am pursuing my Bachelor of Technology in Computer Science from Bennett University. And today I am going to talk about data mining and its concepts. So let's begin the presentation. We'll talk about why data mining is needed, what is data mining, on what kind of data do we mine, what is the functionality of data mining, are all the patterns interesting, major issues in data mining, and classification of data mining systems. So why data mining? The tremendous growth of data from terabytes to petabytes has called for the need of data mining. There are a lot of tools for collection of data, like from automated data collection tools, database systems, web, and computerized society. There is abundant data available throughout the world, like from business, web e-commerce transactions, stocks, from science, remote sensing, bioinformatics, scientific simulation, and from society, can get it from news and digital cameras. So let us now talk about how database and data mining has evolved throughout the years. In 1960, there was data collection, database creation, information management system, and network DBMS. In 1970, relational data model was introduced with relational DBMS implementation. In 1980s, RDBMS, advanced data models, application-oriented database management systems, scientific, spatial engineering, etc. was introduced. In 1990s, due to abundant data, data mining was introduced with data warehousing, multimedia databases, and web databases. And in 2000s, stream data management and mining was introduced, data mining and its application, web technology like XML data integration and global integration management system. So what exactly is data mining? Data mining is the extraction of interesting patterns or knowledge from huge amount of data. Its alternate name is knowledge discovery in databases. So is everything data mining? Like query processing, expert systems, or statistical program? We'll talk about that in the upcoming slides. So why data mining? Data mining is usually used in data analysis and decision support, like in market analysis and management, in target marketing, customer relation management, market basket analysis, market segmentation. It is used in risk analysis and management, like in forecasting, customer retention, quality control, and competitive analysis. It is also used in fraud detection and detection of unusual patterns that are called outliers. Data mining's other applications are text mining and web mining. It is also used in stream data mining, bioinformatics, and biodata analysis. So let us talk about how it is used in market analysis and management. Where does that data come from? It comes from credit card transactions, discount coupons, customer complaint calls. In target marketing, it comes from clusters of model customers who share the same characteristics, interests, income level, spending habits, etc. Determine customer purchasing patterns over time. In cross-market analysis, it is correlated between product sales and prediction based on such association. In customer profiling, it is associated with what type of customers buy what product. In customer requirement analysis, it is associated with identifying the best products for different customers, predict what factors will affect new customers. Now let us talk about how fraud detection and mining unusual patterns is an application of data mining. It has a simple approach of collecting data from clustering and model construction for frauds and outlier analysis. Its applications are in healthcare, retail, credit card service, and telecom. In medical insurance, it is used in professional patients and ring of doctors, unnecessary or correlated screening tests. In telecommunication, phone call model, for example, destination of the call, duration, time of day or week, analyze patterns that deviate from an expected norm. In retail industry, it is analysts estimate that 38% of retail shrink is due to dishonest employees. Other application of data mining are the Internet Web Surf 8. IBM Surf 8 applies data mining algorithm to web access logs for market-related pages to discover customer preference and behavior pages, analyzing effectiveness of web marketing, improving website organization, and etc. So let us now talk about data mining, a knowledge discovery database process. The steps of a KDD process are learning the application domain, relevant prior knowledge and goals of the application, which are creating a target data set data selection. Then data is cleaned and pre-processed, and it may take 60% of the efforts. Then data is reduced and transformed by finding useful features, dimensionality, and variable reduction. Then we choose functions of data mining, some like summarization, classification, regression, association, and clustering. After that, choosing the mining algorithm is an important task. Then data mining search for pattern of interest. Then we have pattern evaluation and knowledge presentation, which is used in visualization, transformation, and removing redundant patterns, etc. Then we use the discovered knowledge. These are all the steps of a KDD process. We just talked about the steps of KDD process in the previous slides. So now we move on. So let us now talk about on what kind of data do we perform data mining. Data mining is performed on relational databases, data warehouses, transaction database, advanced database and information repository like in spatial and temporal data, in time series data, in stream data, multimedia database, and text databases. So what are the data mining functionalities? It is generalize, summarize, and contrast data characteristics. Classification and prediction of data mining. Construct models that describe and distinguish classes or concepts for future predictions. Cluster analysis. Class label is unknown. Group data to form new classes. Example, cluster houses to find distribution patterns. Maximizing intra-class similarity and minimizing inter-class similarity. Outlier analysis. Outlier, a data object that does not comply with the general behavior of the data. Useful in fraud detection and rare events analysis. Trend and evolution analysis. Trend and deviation, regression analysis, and sequential pattern mining and periodicity analysis. So are all the discovered data patterns interesting? Short answer, no. Data mining may generate thousands of patterns, but not all of them are interesting. Suggested approaches are human-centered, query-based, focused mining. Interestingness measures. A pattern is interesting if it is easily understood by humans, valid on new or test data with some degree of certainty, potentially useful, novel, or validate some hypothesis that the user seeks to confirm. Objective versus subjective interestingness measure. Objective based on statistics and structures of patterns, example, support, confidence, etc. Subjective, in case of subjective, based on users' belief in the data, example, unexpectedness, novelty. Data mining is the intersection of multiple disciplines. It is used in database systems, statistics, machine learning, visualization, algorithm, and other disciplines also. Data mining and its classification schemes. There are different views and different classifications. based on kind of data to be mined, kinds of knowledge to be discovered, kinds of techniques to be utilized, and kinds of applications adapted to it. Multidimensional view of data mining. Data is mined on relational, data warehouse, transactional, stream, object-oriented relational, active, spatial, time series, text, multimedia, heterogeneous, and World Wide Web. Knowledge is mined on characterization, discrimination, association, classification, clustering, trend deviation, outlier analysis, etc., and multiple integrated functions and mining at multiple levels. Techniques utilized in data mining are database-oriented, data warehouse, OLAP, machine learning, statistics, visualizations, etc. Its applications adopted are retail, telecommunication, banking, fraud analysis, biodata mining, stock market analysis, and web mining, etc. OLAP mining and its integration of data mining and data warehousing. Data mining systems, DBMS, data warehousing system coupling, online analytical mining data, integration of mining and OLAP technologies, interactive mining multi-level knowledge, necessity of mining knowledge and patterns at different levels of abstraction, integration of multi-mining functions. It is characterized classification, first clustering, and association. Major issues in data mining are in mining methodology, mining different kinds of knowledge from diverse data types, example bio, stream, web. In performance, efficiency, effectiveness, and scalability. In pattern evaluation, the interestingness problem. Incorporation of background knowledge, handling noise and incomplete data, parallel distributed and incremental mining methods, integration of the discovered knowledge with existing one, knowledge fusion. User interaction major issues are data mining query languages and ad hoc mining, expression and visualization of data mining results, interactive mining of knowledge at multi-level of abstraction. In applications and social impacts, the problems are domain-specific data mining and invisible data mining, protection of data security, integrity, and privacy. We are nearing the end of this presentation, so let's talk about the summary. Data mining is discovering interesting patterns from large amounts of data, a natural evolution of database technology in great demand with wide applications. A KDD process includes data cleaning, data integration, data selection, transformation, data mining, pattern evaluation, and knowledge presentation. Mining can be performed in a variety of information repositories. Data mining functionalities, characterization, discrimination, association, classification, clustering, outlier, and trend analysis, etc. Data mining systems and architectures. And there are major issues in data mining also that we have discussed just now.